Today we will review over what we've been learning about circles. So I will go over the vocabulary for circles, and then properties involving central angles and inscribed angles. So let's take a look at this review sheet. Alright, first let's start with some vocab. Number one is talking about arc AB. Arc AB is a minor arc B. So we know minor arc means it's an arc that is less than 180. And while I'm at it, major arc is an arc that is more than 180. And a semicircle is a 180-degree arc. Right, so next part, A, B, C would be from A around to B, around to C. We see that arc is bigger than a semicircle, which makes it a major arc. Next, line QD, which I forgot to draw. Let me draw that in. There we go. QD is supposed to be a line that passes through the center, which makes it a diameter. OB would be, let me use a different color real quickly. OB would be this segment that goes from O to B, from the center of the circle to out the circle. We call that a radius. Segment AC here in black, it's a line that goes from one part of the circle to the other part on the circle. We call it a chord. Angle COB, let me draw that one in as well. Let's use brown. Let's use this color. So angle COB is this angle right here. It's in the center. Your vertex is on the center. It's called a central angle. And last but not least, angle BAC. Let me draw that. From B to A. You can see your vertex is on the circle. We call that an inscribed angle. So let me add those two notes. Vertex at center. Over here, vertex is on the circle. So here are a few things to know about vocab of a circle. Next, the arc of a semicircle is how many degrees? Full circle. We know full circle is 360. Semicircle is half. Semicircle means half circle, which means 360 cut in half, 180 degrees. Next, given that AB is a diameter of circle O, which other arcs is congruent to AC if AC is 90? So they tell us AC over here is 90. So I want to find EF. To find EF, notice that AE EF, and FB. This entire top part right here creates a semicircle, which is 180 degrees. So semicircle, 180 degrees. So to find EF, what we can do is add 10 plus 15 gets me 25. So between this arc and this arc, it's 25 degrees. The entire top half is 180. So what we can do is 180 minus 25 equals 155. Now let's take a look at BC over here. Again, note that from AC to CB is again a semicircle. Now we're looking at this bottom half. So in a semicircle, we have 180 minus this 90 degrees. That's me 90, which means BC is 90. The question is asking AC is congruent to what? Our answer is AC is congruent with us is 90, CB. Alright, in the back. A few typos here that I need to fix. First, this should say quadrilateral EFGH. And let me change some numbers here just so it makes sense. Let's actually change this into a 12A. Now those numbers make sense. And make this 17A. Regardless, quadrilateral EFGH is inscribed in the circle showed what is the measure of angle G. One of the properties we learned is that, let me write the property down. For a quadrilateral, inscribed meaning drawn inside, inscribed, can't spell, whoops. Here we go. For a quadrilateral inscribed in a circle, opposite angles are supplementary, meaning they add up to 180 degrees. So what that means for us is, if I take this angle E and this angle G, they add up to 180. So let's do our work over here. 24A plus 5A equals 180. Combine like terms, 29A equals 180. Dividing both sides by 29. And we get A equals, let's see if I remember this correctly, 6.21. So A equals 6.21, but our goal is to find measure G, which is over here. G is 5A. So lastly what we can do is plug in 6.21 to get 31.05, which is what angle G is. So the key idea here is opposite angles are supplementary for an inscribed quadrilateral. Alright, number 11, which of the following is a valid biconditional? Meaning, remember, biconditional is where your statement goes both ways, forward and backward. So part A, an arc is a major arc if and only if the arc measures more than 180. That is true. We define major arc as an arc being bigger than 180. B, an arc is a minor arc if and only if the arc measures more than 180. This one is false, because we defined a minor arc to be an arc that is less than 180. Part C, an inscribed angle in a circle is a right angle if and only if its sides do not contain the endpoints of a diameter of a circle. So this is one that I actually want to take a close look at. Over here, if I were to draw myself a circle, with a diameter, here's the center. Let's take a look at this top arc right here. This top arc is 180 degrees. We know that because it's a semicircle. Semicircle starts and ends on a diameter. So now let me draw this inscribed angle. Remember, inscribed angle, let me make a note. Your inscribed angle equals 1/2 your arc. So if my arc is 180, 1/2 of 80, or 180 divided by 2, that's 90-degree angle. Or if I move my point over here and draw my angle this way, same deal, this inscribed angle has this intercepted arc. So I also do 180, it uses the same arc, divided by 2, also equals 90. So that is also a right angle. What I'm trying to show here is, let me make a note. For an inscribed angle, to be 90 degrees, the endpoints have to be on a diameter. For the reason shown here. Because your inscribed angle is half your arc. So if your angle is 90, your arc has to be 180. And we mentioned before that a 180 degree, a semicircle, your diameter always cuts a circle in half. So, part C again, an inscribed angle in a circle is a right angle if and only if its sides do not contain the endpoints. That is false, because as we've discovered here, it has to have the endpoints. If it did contain the endpoints, then it would be true. That leads us into number 12. Which of these two angles are congruent? 1 with 6. Angle 1's right here, angle 6 is down here. Notice, angle 1 has this intercepted arc. It's a semicircle. Because my arc is a semicircle, that means this is a right angle. For reasons we've shown here. If your arc is a semicircle, that creates a right angle for the inscribed angle. So your arc is a semicircle, so the inscribed angle has to be a right angle. And angle 6, which is really down here, that's 6. Again, for angle 6, has a semicircle for its arc, which means this inscribed angle is a right angle. So yes, 1 is congruent with 6. Next, they're saying is 2 congruent with 4. We don't know, because that would be true if this was a kite or a rhombus, but we don't know what shape that is. So no, we cannot assume that. Next, BCD, this angle, congruent with ADC, angle 6 over here. We know this is a right angle. We don't know what angle this is. So that's a no. Again, for this to be a right angle, its endpoints need to go on a diameter. But clearly, BD is not a diameter. Last part, ABC, this top angle, congruent with CDA, this bottom angle. We established that. That's a right angle, that's a right angle, so that works. Right, so there you have a bit of recap for the things we've covered so far about circles, which includes vocab for circles and corresponding pictures, vocabulary for circles, and bit about central angle, how your central angle equals the arc, and a bit about inscribed angle, how your inscribed angle is half your arc. So there you have it.